Hey everyone, we're working on our Unit 5 packet in our notes, and this is topic 5. It's about solving linear inequalities. And I'm going to write something here, and then we're going to actually flip around and talk about it for a second. So it says we solve linear inequalities exactly the same as equations, which means that we solve these the same way that we solve equations, except, there's a big except when we multiply / divide, which means when we multiply or divide by a negative number, we must flip the symbol. So take a minute to write that. We solve linear inequalities exactly the same as equations, except when we multiply or divide by a negative number, we must flip the symbol. And you do not, I'm down. So this is what we just wrote down as our notes. Now we're going to do one example together. Remember, it's exactly the same as equations, except when we multiply or divide by a negative, we flip the symbol. So let's look at number 1 right here. 32 is less than 3x minus 4. So normally with equations, I always have my students draw this dotted line down the middle. We have a left side and a right side. And to solve this, I'm going to add 4 and add 4 because these cancel. And I'm left with 32 plus 4, that's 36. Oops. I don't know what that was. That's 36. And I have over here, my 4's cancel, just 3x. Now, I didn't break that rule, which means my symbol stays exactly the same, less than. All right, now I'm going to divide both sides by 3 because that cancels my 3's, and I'm left with x by itself on the left, and over here 36 divided by 3 is 12, and I'll bring down my symbol exactly. And remember, I didn't divide by a negative, I divided by a positive, so that's fine. This is my answer. 12 is less than x. In my class, a lot of my students like to write it the other way. So I'm going to write, or you could write this by switching the x and the 12 and just flipping the symbol. So these mean exactly the same thing. Either of these answers is correct. All right, and now the way that we represent our solution is we can draw this on a number line by sketching our number line, plotting 12. Greater than 12 means I'm not going to shade in 12, I'm going to leave it open. And greater than 12 means I'm going to shade everything to the right of 12. And then we just learned about intervals in topic 4. In an interval, you put the smallest number that's graphed, which is a 12, and the largest number, which is a positive infinity, and we're going to have parentheses for both. All right, next problem. So in our next one, we have -9 is less than or equal to 5x plus 6. So to solve this problem, I'm going to first draw my dotted line right down the middle, and then I'm going to subtract 6. To get rid of a 6, subtract 6. I get -15 is less than or equal to -5x. Now to solve this, I have to divide both sides by a -5. Divide by a -5. And I just broke a rule. I'm going to put a star here and a star here. We must flip the symbol because I divided by a negative. So that cancels. X is by itself. -15 divided by -5 is +5. And my symbol, which started as a less than or equal to, has to switch direction. All right, and now remember, I can also write this, and this is totally separate. I can also write this with the x and the 5 this way and make my symbol face the other direction like that. All right, so number line 5 is shaded in, and I'm graphing all the values less than 5 that way. My interval is -infinity to 5 with a bracket. All right, last one. Now, this last one is some midterm review we have here because we have an equation that has variables on both sides. If we have an equation with variables on both sides, we pick on the smaller of the two, which is a -x, and we try to get rid of that one first by adding x to both sides. I could go like this as well if I wanted to keep that standard. Okay, my x's cancel. 2x plus x is 3x plus 4. I did not break my rule, so I keep my symbol the same, and I have a 7. Now I minus 4 on both sides, and I get 3x less than 7 minus 4 is 3. Lastly, I divide by 3, and I get x is less than 3 divided by 3 is 1. Or you could always write it, some of you guys like it better this way, with 1 first and then x. Like that. Alright, lastly, to represent my solution, number line. Oops. I don't know what happened there. Number line. Plot my 1. I'm graphing the value. I'm not shading in 1, because less than, and I'm graphing the values that are less than 1 like that. And my interval starts at negative infinity, ends at 1. Alright guys, you are, I believe, at homework number 2 in your packet, so you can get started on that. Good luck. Right now, you do not have to write this down. I'm just going to do a little side note. This is just to prove why we just wrote that. So I'm going to write an inequality on this paper. Again, you do not have to write this. I'm going to write this inequality. 10 is less than 20. Now, do you guys think this is true or false? Hopefully, you said this is true. Now, what I'm going to do is I'm going to do something really simple to both sides of this inequality. Both sides meaning look left side and right side. I'm going to divide the left side by 2 and divide the right side by 2. And I get 10 divided by 2, that's 5. 20 divided by 2, that's 10, which means that this symbol right here stays the same. 5 is less than 10. Alright, now I'm going to do the exact same thing, same inequality. 10 is less than 20. Again, that's a true inequality, right? Now I'm going to divide the left side by negative 2 and the right side by negative 2. Same thing to both sides. 10 divided by negative 2 is negative 5. 20 divided by negative 2 is negative 10. If I put the same symbol here, it doesn't make sense. Negative 5 is not less than negative 10. So what we have to do when we divide by a negative, we have to flip the symbol. So our symbol went from less than to greater than. Alright, I'm going to go back to my notes. So this is